Let us ponder upon another genuine and good question: how baroreceptors controls blood pressure. What are baroreceptors? Baroreceptors are nothing but some kind of receptors that that can sense the change in pressure in our blood. How do they do that? What are their mechanisms? They are mainly present in carotid sinus in the carotid artery and in the aortic arch. So they are present in carotid sinus and aortic arch. Okay, mainly they are present in these two places. Okay, now what they do is they send signal to nucleus tractus solitarius. So they send signal to nucleus tractus solitarius, and they do this work always, whether there is an increase in blood pressure or decrease. So when there is blood pressure of 120 millimeter Hg, they are also sending signals to this nucleus tractus solitarius, and this simply inhibits sympathetic and it promotes parasympathetic. So they inhibit sympathetic, promotes parasympathetic nervous system. Now, if there is an increase in blood pressure, then this nucleus tractus, sorry, not the nucleus tractus, these baroreceptors sends signal more signals to this nucleus tractus solitarius, and as it sends more signal, this nucleus tractus solitarius, what it does, it just inhibit this sympathetic nervous system mode and also activate parasympathetic mode so that the blood pressure can be decreased to its normal value, or it can be bring back to its normal value. Now if blood pressure is decreased somehow, then the signal the baroreceptor sends less signal to the nucleus tractus solitarius, and then the nucleus tractus solitarius, which is present in our brain, it stimulates sympathetic and it inhibits parasympathetic, and that's how it can bring the value of blood pressure to 120 millimeter Hg. Now why it has some limitation. This baroreceptor has some limitations. What are those? It can work in a range of 80 to 180 millimeter Hg. So if the blood pressure is less than 80, or if the blood pressure is more than 180 millimeter of Hg, these baroreceptors cannot do anything. And also there is another problem. It is not 100% efficient. If suppose blood pressure is 180 millimeter Hg, and then the baroreceptor can bring it back to 140 or 130, it can, but it cannot do 100% work. It needs support. Now if suppose a person have always a high level of blood pressure, suppose it is 140, now the baroreceptor accommodate itself with it, and it start thinking, it start behaving as if 140 is the normal blood pressure. Then what it does, it actually it previously it was sending normal amount of signal to the nucleus tractus solitarius when the blood pressure was 120, but now as it thinks that 140 is the normal blood pressure, so in 140 also it sends that normal in 140 it is sending the normal amount of uh, stimulus or signal. So it now it doesn't work to bring the blood pressure back to 120, because it thinks that 140 is the normal value. So it's another drawback. But there are some pros to it. For example, it can quick very fast. So it is another pros. So pros of this baroreceptor is it can quick quickly function. Okay. Bye bye. See you next time.